Alright, hello everyone. It's May 13th. I'm doing this now on the laptop without power source, so I'm relying on the battery, and my laptop really drains battery really fast, so let's see if we can do it before the battery dies. Alright, let's take a look. Anything that we need to be... Nope. I don't remember any of those questions. Alright, May the 13th, let's do it. May the 13th, ambiguous coordinates. Okay, let's take a look. We had some two-dimensional coordinates, blah and blah. Then we removed all commas, decimal points, and the spaces, and ended with the string s. Return a list of strings representing all possibilities for what our original coordinates could have been. Okay, our original representation never had extraneous zeros, so we never start with numbers as some numbers like 0, 0, 0.0. So extra zeros are not likely, okay, or any other number that can be represented with less digits. Also, a decimal point within a number never occurs without at least one digit occurring before, so we never start with 0.1, okay? The final answer list can be returned in any order. Also know that all coordinates in the final answer have exactly one space between them occurring after the comma. So basically you're given a parentheses, right? And there's only one set of parentheses. Yes, the length is 4 to 12. And the first is a parentheses, the last is a parentheses, everything else are digits. So we're gonna split it, right? We're gonna split it using comma or decimal points. Okay, that's fine. So for 1, 2, 3, I mean, apparently we can start with, let me think, no decimal points, right? If it's no decimal point and then everything has to lead with a number, right? So we can say, and 0 by itself is, 0 by itself can be allowed, right? So if it's a 1, 2, 3, and we do it by numbers alone, so we just put comma in different places. So we have two, either 1, 2, 3, or 1, 2, 3. That's the first two, yeah. And then we say let's add decimal points. If we add decimal points, decimal point can only be added. It's the same thing, right? Same as the comma. Hold on. What we can do, we can use comma because comma determines the two sets of numbers, right? And it's guaranteed that a comma will not be happening if there's no numbers. So we can use comma to divide the numbers. And then we try to see within each comma-fication, within each category of comma, can we put a decimal point in it? And in this case, right, we have two cases with a comma, and we look in the first case. In the first case, we want to put decimal points. Now we cannot put it in the first one because there's a single digit. It's not possible to put a decimal point. But here we can put a decimal point. So that's 2.3. And then for 1, 2, we can put a decimal point here as well. Okay. All right, let's look at this. We have 0, 0, 0, 1, 1, right? Again, we want to comma first, but immediately we realize that a comma is not possible because anywhere we put a comma, we will encounter leading zeros, right? So this one, comma is not possible. So we have to do comma is still possible. We can still do comma. Because if you look at it, we only have 4 to 12, so we can do comma. So we divide it into comma, right? So it's 0 with 0, 0, 1, 1, and then 0, 0 with 0, 1, 1, then 0, 0, 0 with 1, 1, 0, 0, 0, 1 with 1. So that's the result of commas. And then, so we have 1, 2, 3, 4, 4 different cases. And in each case, we try to see without comma, or without decimal point, can it work? So the first one, 0 with 0, 0, 1, 1. No, without comma, we cannot, because 0, 0, 1, 1 is the leading 0, right? So that cannot do. So then we ask, can we add a decimal point? I mean, 0 we cannot add decimal point, but 0, 0, 1, 1 we can, and we try a different point. So 0.0011, that's this one. That's good. So we can do 0.011, and then we'll move on to the next one, becomes 0.11. Then that's not going to work, because 0.11 has leading zeros, and then 0.1 is also not going to work. So we only have one lead. So yeah, we can only afford 1 0 ahead of 1 0 ahead of the comma and 1 0 ahead of the decimal point. So this one can only generate 1. So next possibility is 0, 0, 0, 1, 1. Now the comma doesn't work because we have 0, 0. That's 2 zeros in front of the comma, and the decimal points. It also doesn't work. We have to check both, because we can put decimal points on both, right? We have to check on both. So comma doesn't work. Now decimal point. So comma, it depends, right? So comma, if a comma works on both sides, and that's good, that's one solution. If comma doesn't work on both sides, and then we need to try how to do it systematically. So we do the comma first, and then check if comma itself, like an integer, does it work? If it does work, that's good. If it does not work, that's fine. Then we try to apply a decimal point. So a decimal point apply on one side. So 0, 0, 0, 1, 1 apply on the 0, 0 side, doesn't work. That's a 0.0, doesn't work. So then we say we apply on the other side, 0.11. Oh, if it applies on one side, it doesn't work, then it's not going to work. All right? If I apply it and it does not work, and that's just not going to work. So comma, we can check work or not work, right? We work, and then, because the decimal point can be on one side, and then the other side can be left as integer. Okay, and the next one is 0, 0, 0, 1, 1, right? And then this one will come up as comma doesn't work, but it works on the second part. So the second part works. So when we check the decimal point, check the first part for the decimal point, and the first part for the decimal point does not work. And then the second one, we need the first one to be comma, and it does not work. And the last one is both to be decimal point, and that also does not work. So we say that doesn't work anymore. Okay. Last one, 0, 1, 2, 3. So we have 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Right? That's 3 comma situation. On the first comma situation, it comes out both work. So both comma work. So 0, 1, 2, 3 work. Now we're going to check on the left decimal point. The left decimal point doesn't work, so we don't do it. Right decimal point. Right decimal point, we can have 2 decimal points, right? And then it works. 2 decimal points, it works. So we have 0, 1.23 and 0, 12.3. And then we try both decimal points, and that doesn't work because the first decimal point doesn't work. And the next one, 0, 1, and 2, 3. Comma doesn't work. Decimal point, comma doesn't work because the first one doesn't work. So decimal point, we'll call the first one, that works, 0.123. And that decimal point on the second one, it doesn't work because the first one, the comma doesn't work. And the third case is both decimal point. That one works, it will be 0.1 and 2.3. Now the last one, comma doesn't work on the left, but it works on the right. decimal point on the left, we have 0.12 or 0.1.2. 0.1.2 doesn't work, so we don't consider it. So 0.12 and 3. And the decimal point on the second one, it doesn't work because the first one, the comma, doesn't work. However, we can do both decimal points. So that's going to become 0.12 and, oh, no, because the second one has no decimal point. So it's just 0.12 and 3. So we have 1, 2, 3, 4, 5, 6 possibilities. 1, 2, 3, 4, 5, 6. Okay, we kind of know how to approach it, but the programming side, what would be the sufficient way to program it? Recursion, right? We can do recursion, and we set up a cache, right? Which means when I'm faced with, so given a string, right, we need to know how many times the string can be split in. That's not true. We don't have to. We split it by comma first, right? We split a string by comma, and then we have the resulting string, resulting like substring, whatever. And in the resulting substring, each one, the left side and the right side, right? And then the left side and the right side, we need to go through a bunch of checks. We check left for integer, check right for integer. And I think Python can do this very easily. Let's take a look. So, which means like if I have a 0, 1, right, and I call int a, that gives us 1, can't really see it, but if I do str and then do int a, that's 1, that's not equal to, and the same thing if I say, oh, I don't know, 0. Let's say 0.1, right? And then we say, no, what I'm doing. So we're going to 0.01. Let's do this, right? And then, oh, can I do float b? Oh, I can do float b. Cannot do int b, can I do float b? And then we can do int str, float b. There we go. That's how we check if it's possible or not. So we split it into integers, and then for each one we have left part and right part, and determine if the left part is good, right part is good, and left part turn into there are many ways we can turn if it's possible. So we have to do also split that into commas and into not commas, into what I'm thinking decimal points, right? Split to decimal points and then check. Okay, yeah, let's do this. I think it might take us some time to figure out the intricacies of getting the code up, but I think it's definitely doable. That's way too big. Oh man, it's way too big. Okay, so what do we have? We're gonna go to the start, V, and select all these, C, come back here, copy and paste this. Right, so we're gonna split by comma first. How do we do it? All commas, right? It's gonna be here. I'm gonna say for I in range. So we have to do 0, 1 from 1, right? So I have to set 0, 1, 2, 1 and 2. So range len, I should say from 1 to len s, right? So what we're going to do here is going to be another one that's going to be s towards I, and SI towards the end. All right, so that's that. Actually, I think this one requires a little bit different because I need to check every single step instead of blindly just code it. Let's do the most complicated. All right, let's do this. Oh, shoot. That's also not include the left and the right parentheses. All right, that's just adding confusion to us. So the result gonna be this. That's actually our result might be slightly different because I don't think I will. I do think we have to change the order, but that's a story we're gonna talk about later. Okay, so this one is going to be ambiguous. All right, so all commas, that's not correct because we're gonna start. Let's say work. Actually, it's not necessary. Let's just. No, it's necessary. I'm gonna say work s. Work str is going to be s, going to be from 1 to -1. Right? We're gonna eliminate the left and right parentheses. And all of these s is going to be turned into work str. Right? So when I print all commas, just give a note 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Yes, that's exactly what we want. And then I'm gonna say res is this, and then for L and R in all commas. Right? I'm gonna check L int equals int L, no, int str int L equals L, right? And then right int str int right equals R. So this is to determine whether both can be represented as integers. And we say if L and R, then res.append. Okay, the result has to have parentheses with it. So it's going to be shoot, L and R F string to this rescue. So it's gonna be right left parenthesis right parentheses, and this is gonna be L and comma and R, right? So that's the first if both, right? And then on the left side we're gonna try for the same thing. Let me say all if we have the right, no, we're gonna do left. We're gonna do the left side. The left, I'm gonna say left L decimal points. It's going to be similar thing. Decimal points, all possible decimal points, right? So it's gonna be the left decimal points can be for, let's go also for I in range 1, right, to len L -1. This is all the decimal point possibilities, and what we're gonna say is gonna be L I plus decimal point plus L I to the end, right? This is all possible left decimal point, and of course we can do the same thing with all the right decimal point. So we're gonna turn L into, oh shoot, this len has L as well. Alright, just do it this way. So this is going to be R and this is going to be R. So we have the left and the right decimal points. Now the question is, if we need to find the valid left and the valid right, right? Which means if I can know it from here, that will be even better. Which means we're gonna say, let's see, I think it's possible to use the walrus here. So it's gonna be left decimal. Let's say T walrus, this thing, right? I do remember you have to use this. If what? If float, if str and float t equals t, else, actually I don't want it this way. Oh man. All right, that's too complicated to do it this way. I think I'll just by the bullet call it here, and we just say for same thing here. It'd be easier, right? For this temp, I want to call it temp. Just write it out. Temp is equal to this thing. All right. If say str float temp equals temp, then L decimal point dot append temp. This is to get all possible left decimal and all possible right decimal as well. So it's the same thing here, but again it's gonna be right, and here this and that. These two gonna be right. I believe this is also right. Okay, so we get the left possible decimals and the right possible decimals, and then crisscross them, right? Left and right plus again, if L int, actually this is L int and the right int. Right, if left integer is good, then we're gonna say for right decimal in right decimal, res.append this left is good, and this can be right decimal. That's if left integer is good. And then the same thing, we're gonna say if right integer is good, then we're gonna go left decimal. All the left decimals will be left decimal and the right integers. And finally, we're gonna say for left, that's a FD, that's not FD, it's left decimal. There's also left decimal. For left decimal in left dec, for right decimal in right dec, res.append f. I feel like this could be simplified, but let's just first left decimal and right decimal. Let's just first do it, and then we're gonna handle it. Okay, now we're gonna return res. Spell it wrong. Return res. Okay. Answer and a result. Well, we feel short. Well, a lot short. If left integer, we go right. If right integer, we go left. And then we go left or right. Okay, so answer, we have this. We don't have 0 and 12.3. All right, we have problem. Let's check here. I'm gonna print left decimal and print right decimal. Let's see if we get so we probably also need to print out what is the left and right at each position. So the left, right, the first one is 0. That's good. Yeah, that's, we only have 0, 1, 2, 3. And we have 0, 1, 0.2. How about 12.3? How about 12.3? I think that's the one we're missing. Okay. In range. Oh, I think it's not -1. I don't know why I put -1 here. One, two, three, four, five, 6. Yes, then this one's correct. Of course, the local test will not be accurate because there is, I need to sort. How about we say sorted res equals to sorted answer. There we go. All right, I think, yeah, it's complaining. It says it's ambiguous, but that's fine. Actually, we have more test cases. Let's run more test cases. And what are the other test cases? Now we sort them, so it's fine. So we have a 1, 2, 3, and this one will get a this. Next one is this. I want to handle all the parentheses, not parentheses, the quotation marks at the end. And we're doing this. The last one is this. And output. That's not a correct output because it's supposed to be quoted. Okay, and we're gonna handle all of these. They're gonna have to be this. All right, try it. Ooh, we got some issue. 0.0. What the hell? Are you telling me 0.0 is not considered? Okay. I was trusting on Python to do this, but apparently it's not. What? 0.0. If I say, what? str float a. It's 0.0. So we have to handle 0.0. So we handle 0.0 by if this equals temp. And I think it only happens if we have 0.0. Right? So if floated equals temp and how do we determine that it's actually I think only have what if we have a say 0 point like this. It all refers to 0.0, so default only 1. Okay, so the only thing we need to worry about is and is this and temp. The last two is not equal to 0.0. If it's 0.0, we don't consider it. And it's the same thing, right? We're gonna consider the same thing here as well. And this, I'll have two ends. There we go. Okay, so we pass all the test cases. Let's try here. Oh, I may be able to solve this with rejects. I'll try, see if it passes. Oh, we have a wrong answer. Do you want to see? Then we just started. I just don't want to see. I know this feels like too hacky to me, right? This feels too hacky. Doesn't feel right. What could be the wrong answer? I don't want to see. Let's refresh it. There we go. It's gone. Let's try this. Maybe we have error here. Oh, this one's good. How about 2 digits? Like 2 good digits. Okay, 2 good digits is good. How about, can we do 0, 1? Yeah, we can do anything we want. Okay, that's good. How about a bunch of zeros? Oh, did we go beyond? 1, 2, 3, 4. Oh, look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How does this one fail? I don't know. Is it failing with 0.01 already? No, this one is good. Wait, are you telling me like based on the number of zeros? That is bonkers, man. That is bonkers. See, this one is still correct. Why? There should be enough time. This one is still correct. How? How we have like more zeros in the leading position than it failed? All right, this one failed. Let's see. Print left, right, left decimal. Yeah, left decimal, right decimal. Let's print a separate line. Print left decimal. I can actually test it on my thing. Yeah, let's do it on my thing, so I don't have to worry too much about waiting every single time. So we have something error here. This, and the result should be this. And yep, that's not correct. Okay, let's do it here. Print left and right, and print left decimal, print right decimal. Take a look. This gives us nothing. It only starts give us something in here. Oh, I know. Trying to cheat my way through this. Python does not allow this 0.00000001. If you float this, that becomes 0. Oh no, that becomes this. Man, shouldn't mess with zero. Shouldn't mess with zero. Float at all. Yeah. Okay. That's fine. That's fine. I mean, that's when we want to do the float. It's pretty straightforward. If the leading is a 0, then there's only one position we can put it at 0 point something. Right? That's the only position we can put, and we have to guarantee that. All right, let's do analysis again. Giving you in a string, right? A string of numbers. If the last one is not okay, like this, giving you a string of digits, right? If the first one is a 0 and the last one is also a 0. You can still put in it. It has to be on the first one, because you cannot put 0 something dot, right? Yeah. Yeah, this has to be solved by regex, I feel like. This is just, I'm analyzing the heck out of it. So the first one, if first one is 0, and the last one is also, it could be, if the first one is, it depends on whether this value is 0 or not. Okay, so several things. So this one is good. Integer, we can do this, no question. But the decimal points, it's a little bit tricky. So we have to say, if L or R, if it's 0, right? If int this is a 0, then there's no decimal points whatsoever, right? Else, if it's not 0, then we can check if the front is not a 0. But that could be integer. Right? That could be an integer. No, I think ending 0 is also not allowed. Like if we do 1, 2, 3, 0, ending 0 I think is also not allowed because it can be shrunk down. Oh, let's see. Yeah, ending 0. Like we cannot do 3.0, right? Ah. Yeah, ending 0 is also not allowed. So what? So we're given a value, and then what? Then we say if this value is, we float it and compare it to integer. That's how we determine whether it's an integer itself. Like in this one, if we say 1 to 30, right? 1 to 30, and 1, there's no point, we cannot turn it, but 230 we can turn it. 2.30, and we say 2.30 is not correct. And 23.0 is also not correct. That's only the two way of doing it. But we can do it because the first one is 2. I mean, 0.0. I don't think we have 23 expected, and so my answer is here. Yeah, I don't have like, again, so let's say this is 12.30, right? str float, it's 12.3. It's only 0.0 that it will. But how about 23.0? 23.0. That will go back to 23.0. But how is that one not counted? I didn't see 23.0 here. Right? I don't have 23.0. Which part that eliminated? Oh, because I have 0.0. There's a check. Okay. So when we do the point, right, we can actually just get two parts. And the right part cannot end in 0. Okay? The left part cannot have 2 leading zeros. Right? That's a rule. The left part can be 0 by itself or any other values. The left part has to be Yeah, the left part has to be an integer, and the right part has to be an integer. Without ending, does not end in 0. That's it. The left part of the decimal has to be an integer that is not a... Yeah, the left part has to be a valid integer with no extra leading zeros. And the right part can be anything except it cannot end in 0. Which means what we're going to do here is, this is still good. So we have left and right, and we're divided, right? So we have this, and we're going to say left temp, right temp equals this and this. And we do the same check, exact same check. When I say if str int left t equals lt and lt last one is not ending in 0. It's not 0. Actually, we just need the lt. We don't even need. We can just say, oh, we actually do need. Yeah, we just say the right side, it does not end with 0. If we satisfy this, then we can put left decimal going to be lt plus a dot plus right t. Right, and then we're going to copy the entire thing for the right decimal as well. This is going to be, that's the same, just this is going to be r. This is r, this is also r, and this, and this is going to be r. Right, and now we pass. Yep. Try it again. This one is upgraded. Try this. 1230. Well, how many? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, I think it's correct. 1230, 1230, 1.230. Yep, let's try it. All right, again. Pending. Yes, got it. Got it. All right, so that's the trick. Split always use integer. Integer is the only one that's reliable. And then we do the left and the right, and then we append them. That's pretty straightforward. Pretty straightforward. So we first apply commas to divide s into two substrings of digits. If both the left and the right string digits are themselves integers, that is one. That is a result already. Then we partition the L and R into possible decimals, respectively. The rule for decimals is that after the partition, the left portion of the decimal is a valid integer, and the right portion does not end with a 0. After obtaining the left and right portion. Now after obtaining the valid decimals for the L and R, we assemble the rest of the result. If L is a valid integer, we add all valid right decimals to it. Same with when R is a valid integer. Finally, we add all combinations of the left and right decimals. I'm not talking about runtime. What's runtime? Runtime is this is ON. This ON. I think it's like ON squared. Grand scheme of things, that's what I think. Because we have to do this part, right? Go through each one of them. And at least this part. Go to each one of them. Yeah, I think it's ON squared. Let's just call it ON squared. Alright, let's take a look at the details. Medium performance, 48 milliseconds. We get a 61% ranking. I don't say it's hard, it's just a lot of considering. I mean, like, looking this way, it doesn't look as bad, right? FLint, FY. I mean, we can write this as separate functions. If I write this separate functions, it'll look much nicer. All right, let's take a look. Maybe the correct solution relies on regex. Yeah, maybe regex can do this. Yeah, I guess not many people like this question. Maybe it's a medium. It could be an easy. I still like it. All right, only we have ON to the third. Oh, really? That's to the third. Oh, I thought it's squared. Place to put comma. We separate the string into two fragments. We have a choice of whether to put a period. Create a list of choices. Yes. Ignore possibilities where the part of the fragment to the left starts with 0. And ignore the possibility with the right. The part on the right that ends with a 0. Oh yeah, it's the same, but I think they did a little bit better with here. So you can check, right? So if the left is a 0, or yeah, I think it can be like the LT is 0, or LT the first is not a 0. Yeah, it's the same. It's the same solution. But they say, oh Lord, look at them. They use yield. Oh, they use a product. Ah. Okay. Okay. Candidate. They get all possible candidate and use product. Makes sense. So they also consider the fragment as each fragment. On the left and right. If Oh, we have a starts with, ends with. Yield left dot plus this. If D is not equal to this, else this plus right. I see. I see. I see what they're doing. Okay. Results output because of sum. And to the fourth to build it. Well, O(n) to the fourth. So O(n), that's the first level. This is O(n). And then all right, well, that's actually hard to, so is this also considered O(n)? And when we go inside, the make is, and then this is O(n). This is probably also O(n). Yeah. Doesn't look like O(n) to the fourth, right? So we have O(n), first level is here. And then when you do two making here, the making here, this is O(n) because there are n candidates, so that's O(n) squared. And then coming in here, each make, we have fragment that most is also O(n), so D is O(n). And finally the yield is O(n), so it is O(n) to the fourth. All right, coming here, this is O(n). Oh, I hided this. This is O(n) squared already. O(n) is here, right? To make this, and then we iterate through each one of this. Yeah, this is O(n). O(n), that's O(n) squared. Coming in, this is O(n), and this is O(n), and this is O(n) as well. Yeah, so I think it's O(n) to the fourth. Makes sense. Should be O(n) to the fourth. But we can do better. Not in terms of runtime, I think. In terms just of logic. This still seem a little bit convoluted. I mean, we don't have to do product, right? We can just divide into two parts. And we need these, right? We're going to divide it into two parts. And we can directly do it here. So we can just say for L and R in this, right? And we can make, basically say all the possibles on the left and all the possibles on the right. Okay, I like this idea. Yeah, let's call it make frag. That's a good way to call it. This is gonna give us a list. Oh, that's why they do it as a yield, because we can yield. If we yield left and right, now let's just do this. I'm kind of lazy. And then also list of str, right? So to make this, it's the same thing. When I say for I in range from 1 to len frag, right? And then we have LR equals frag towards I and frag I this. And then we say the left cannot be what? The left cannot be starting with 0. And the right cannot be. Ah, then you don't have to return it. Otherwise, you have to return a list. Yeah. Let's just return a list. That's fine. So we just say if left 0 is, if left is a 0, or left 0 is not a 0. That's the characteristic of the left that is correct. Right? And then we say if left is this, what else? Or left, what if the left is 0 and not 0 and we have 1, 2, 3, 0 and a 0 something? I mean, right, like 1, 2, 3, 0, 1, 2. Or split 1, 2, 3, 0 and 1, 2. And then 1, 2. Oh, we're doing a 1, 2, 3, 0 here, right? We're doing 1, 2, 3, 0 here. So in a split, and the right side, when we cannot end, so we keep going. So these are now good, now good, now good. And eventually we end up 1, 2, 3, 0. That's fine, yeah. So if this and okay, what am I returning? I'm returning a possible. So if this and, right, and, so this is the left side, right? This is the left side, and the right side has to be not ending with 0. Ah, that's why it says start with 0. Okay. L dot start with 0. Like, not start with 0, and right dot end with 0. Alright, and not ending with 0. I'm pretty sure if we go to, that's not intentional, we just open a thing that I don't want to open. Okay, so A is this, A dot end ends with 0. Yeah, how about 23 dot ends with 0? Then we say it's not ending with 0. Like, how about this ending at dot ends with 0? That's false. Nice. So that's why I use this. If left and right, so I mean these are true, then we say rest dot append. We should do the yield then, right? Yeah, imagine if we say yield. Yeah, then we don't need to append this. And this is actually, I forgot how to do the typing for the generator. So when it yield L plus this plus R, right? However, if the left is an integer by itself, right? Then if the left is an integer, well, then we shouldn't be, this is going to play +1. I think this has to be +1, right? Because from 1, 0, 1, right? And then we do this. Yeah, we'll have to +1. And then this is going to be, if it's 0 or if it's not, start with 0. And this plus this if I is not equal to len We have to do len here. So we say n equals len frag. We're just getting closer and closer to the optimal solution. And I is not equal to n, else gonna be this n plus. All right, and then for this, and then we say make left and make right for okay, let's see the iterator. From iter tools, import product. Right, if I say product iterables, so like one, let's say 1 and 2, and on this side 3 and 4. Let's see what we have. Right, this one, oh, I have to get a list of this. So we'll get 1, 3, 2, 1, 3, 1, 4. Okay, so yes, that's what it is. So we can do this. Let's do from, let's just import iter tool. I think I can say from iter tools import product. Okay, so we're gonna say here from like C1, C2 in product make self.make left and self.make right. So both gonna be iterables, generators. So when it comes out, when I say res.append, right? Append what? Append this, and this. C1 and C2, because C1 and C2 is all the possibilities. And when I return res. Alright, let's try solution 2. Ooh, positional argument, but 2 were given. What? Make self. Oh, forgot self. Okay, ends with, not end with. Probably starts with. There we go. We pass. Okay, I'm gonna check on the others. They all pass. Well, I think this is a better solution than mine. Well, this is the official solution. Okay, so we're gonna try this. Call it. This is the official solution. Actually, if you look at it, it's quite similar, right? If not start and or if it's a 0 and not ends with left plus else, yeah, it's the same. It's exactly the same. This one will be, yeah, it's the same. So this is the official solution. I'm gonna also link it. All right, also link. So this is the official solution. This is the official solution. The same idea, but I think it has a better implementation because it does not separate the integer check and the decimal check into two different processes, two different steps. Instead, it combines the two. Thus, we can call iter_tools.product when we obtain the final result. Also, the use of yield is definitely definitely a good touch. Not necessary, but I think it's a good touch. Yeah, so this we combine, so we say this is a check for integer and decimal is combined. I definitely like this touch. It's combined together. Okay, I see discussion. See what kind of complaint people have. Really clear Java code. Oh, it is O(n) to the third. All right, it is O(n) to the third. I just believe other people's comments. Yeah, I think I know about this in the past. N minus k plus 1 times k. This is just way too much. Wait, what is this? If return this. Yeah, I mean we understand how it goes, but and the correct complexity. All right, let's think about complexity again. Man, I hate to do complexity. Sometimes it's very. So okay, so the first level, right? Let's write it out. First level. Let's see. So we do that's n times, because that's the n times. The problem is in here, right? In here. So we call it product self.make L and then self.make R. So in here, what do we have? On the one side, we have, let's say the fragment contains k, and the other fragment contains n minus k, right? On the k side, we go through everything. So be k be 1 plus blah, 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 plus 2k. And the right side is also 1 plus n minus k. And then that, I don't know. Let's see. Complexity. O(n) wedges split, yes, or time space complexity. Number of ways will be approximately, each of them have length. This one also says O(n) to the fourth. I don't know, man. I'm confused. Very, very confused. He didn't even check. He didn't even check for len s. In range 2. Oh, hold on. Hold on. He did not get rid of the L and R. Hold on. And this one didn't even check. He put the point on every single one of them. How could you do that? That's... Oh, I think he's doing, if this is this, if s is 0 or s 0 is not, then append s. Then answer.append s. Generate I to the end. If s is 0, then we append 0. Or if is not. Oh, yeah, that's an integer. The integer, you consider integer here. Split s into 2 parts. Overall time and space. Number of ways be approximately n to the third divided by 6. Each of them has length n. I don't know. I don't want to get into the nitty gritty of the time complexity. It's only taking a while. With n smaller or equal to 10. I mean, what is this? K, n minus k plus 1. I mean, that's the combined step. Yeah, I think that's the combined step. Right? That's the combined step. If you think about it, we do this product. It's the combined step. So the L, when we make L, if you think about the best scenario, I just think about the worst case scenario. It's also like the best case scenario for us to estimate this. One, two, like all ones, right? All ones. So we can put commas everywhere, and we can put decimal points everywhere within each segment. And this is going to be ON, the overall, right? Overall is ON. So now we go inside. Now we go inside. Now we go inside for each one of them. The combinations for the L is going to be divided into K, right? L is going to be divided into K different decimals and integers. R is going to be divided into N minus K different integers and decimals, right? And then the product just means it's going to be K times N minus K. So this complexity is K times N minus K, right? And that is for, actually you're using this, right, for each I. So this actually is I and N minus I. And we're going through this I times, so we're going to go sigma I equals 1 towards N, and I times, oh yeah, that's N to the third. This is correct. It is N to the third. Yes, I now understand what this means. Yeah, that's what I think. I think it is N to the third. I'm going to leave a comment. I think it's N to the third. I also think this is what this one's trying to say. We evaluate. Unless the string building, okay, I think I know what they're saying. It is the last step. This step, depending on whether you count that as ON, right? Well, it's a fair point. If you count that as ON, I mean, it depends. It depends. Well, depend on whether depending on whether one counts the final string building as ON or O1, the complexity is ON to the third, to the fourth, or ON to the third. Depending on whether, yeah. Oh, that's where my badge is. Okay, so it's, yeah, I'm gonna write it here. All right, Lee 215 has a good analysis. Actually, no, I'm gonna for complexity analysis, see solution 2. Yeah, I'm gonna write more on solution 2 about complexity. Okay, so here is going to be regarding complexity. Lee 215 has a good formula, to follow. Okay, always reference them first. Okay, reference here. So, in the outer loop, right, we go with I. We go with 1, 2, 3, towards N, right? In the inner loop, the self.make L has OI. Self.make right has O n minus I, right? O minus I. Yes. And then also we're ignoring this as well, right? We're ignoring, yeah, O minus I. Thus, the product has O, I, N minus I. Thus, the total is 1 times N minus 1 plus 2 times N plus 2. Okay, I don't think this is correct. Product. No, this is the product. So the product has this. Hold on, what does the product has? The product has... Isn't this is the I times N minus I? And I'm going to sigma this. Sigma from I to N. Is that this formula? Yeah, I think so. N minus K times N minus K, yeah. So is this plus 3 times N minus 3 plus da 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 plus N times plus N. 1, 2, 3 all the way to, actually going to N minus 1, I think. At the end is N minus 1 times 1. Alright, and then the result is going to be O n to the third. Yeah. Someone says it's O n to the fourth because they count string building as O n. I don't think so. Yeah. I don't think so. Okay, so this is going to be n plus 1 O n n k 1 plus 1 k minus k squared. Yeah. Yep. All right. I think that's it. That's it for today. Yeah, the complexity is always hard from time to time. And we have 25% battery left. So we did it. We did it. All right, that's it. That's it for today. I'll see you guys tomorrow. Adios.